Hi, hello. This is Rishi and welcome to your favorite YouTube channel, Science with Rishi. This is the video number 4 of the chapter Units and Measurement, Class 11, Physics. Welcome. Let's start this video with another new topic, significant figures. Whenever we are measuring some value, there is a chance for some sort of error, right? Because of the errors that we have explained in the last video, there can be some error. For example, if I measure a value and if I got 1.678, whatever be the unit that you don't matter right now, and if you are measuring, you may get some value around 1.673 or 1.677, right? So whenever we are writing a value like this, we are assuming that, okay, the last digit, this can be uncertain, while the other digits, they are accurate or they are okay. Simply speaking, they are okay. Which means, in general, when we are writing some value, we will write all the certain digits and one uncertain digit. And significant figures is the number of certain and uncertain digits in a measured value. Now we have got certain set of rules which will tell you how many significant numbers are there in a value we have measured. The first two are very simple, they doesn't need much explanation. What are they? The first one is all non-zero numbers are significant. Very simple, right? And the second one is all the zeros between two non-zero numbers. All the zeros between two non-zero numbers, they are also significant. For example, if I take 91, both 9 and 1, they are non-zeros. So there are two significant numbers. If I take 102, 1 and 2 are non-zero numbers, they are significant, and this 0 is between two non-zero numbers. So there are three significant numbers. 1 0 0 0 4. How many? Exactly 5. Right? So the first two rules are very simple. Now the third rule, listen carefully. If a number is less than 1, all the trailing zeros to the right side of the decimal are significant. Let me explain with an example. The number is less than 1. Okay, the number is 0 point. And all the trailing zeros to the right side of the decimal. This 0 is in the right side of the decimal. The rule says this 0 is significant. Now that may confuse you a little bit, because in our childhood days, what we have been taught is 0.15 and 0.150 are same. We don't have to write this 0. Now why suddenly such a change? This is because significant figures, the number of significant figures in a digit gives you the precision of that number. Okay, so let's take these two values, 0.15 and 0.150. In 0.15, we are measuring only up to 2 decimal places, right? But here, we are measuring up to 3 decimal places, and we are finding out that the value at the third point or the third digit is 0. So which one do you think is more precise? Of course this one. Now let me increase 0.1500. This one is more precise. We are measuring up to 4 decimal places, and we are finding out that the third and fourth places are 0, which means this is more precise than this. Which one is more precise than 0.15? Here I will say 0.15 has got only 2 significant figures, while 0.150 has got 3 significant figures, and this one has got 4 significant figures. Now you might have understood why this 0 is significant and why we say there is a change if you write 0.15 and 0.150. Okay? Now the fourth rule says you that if a number is less than 1, all the zeros to the right side of the decimal place before the first non-zero number are insignificant, which means these two numbers are not significant and we have got only one number which is significant and which is 5. And fifth rule says if a number has got no decimal points, all the trailing zeros are insignificant, which means they are insignificant and these two are significant. Now this will disturb you, right? You may think why these two zeros are not significant, similarly why these three zeros are not significant. Let me explain you. Let's take this 0.005 is written in kilometers, okay, which means this is 5 meters. We are writing in this digit or in this method because we had to write because we had to convert this meter into kilometers. So these two zeros, they are not standing for the precision, they are just standing because we had to convert it from meter to kilometer. They are just holding their place value there, they are just holding their position, they are not giving you the precision. But instead, if we had written it 5.0 meters, then the case has come different. Okay, 5.0 meter means that the precision is coming, which means they are saying that yes, I have measured a value up to 1/10th of a meter and I have found that that point is 0. In this case, this will come as 0050 kilometers. I mean 0.0050. And because we know the last one is significant, we have got two significant values here and here also two significant values. But these two zeros, they are just standing holding their values or holding their position. They are not giving you or they are not interfering in the precision of these values. Okay. Now let's take this example, 35,000. What is the problem with this 35,000, for which we are not taking these three zeros, we are taking only these two, 3 and 5. 35,000, if I say 35,000, that doesn't give you that doesn't give you a precision, right? We are just saying it in an approximate manner, 35,000. This can be a number which was rounded to 35,000. This can be some value, something like 34998 or 35002, something like that. But we are not sure whether this is exactly 35,000. So here also these three zeros are just holding their position. They are not giving you the precision. If it was exactly 35,000, there should have been a decimal point here. There should have been a decimal point here by which we will say that okay, this is exactly 35,000 and the number of significant figures will come up to 5. But because there is no decimal place, we are not sure that this is exactly 35,000. This is somewhere around 35,000. This 30 doesn't give you an accuracy or precision. Sorry, these three zeros, they are not giving you the precision. So these three are not counted, only these two digits are counted. Hope now this is clear for you. Yes, you can just keep it in your mind that okay, these two zeros are not significant and these three zeros are not significant, but you must understand why it is. Otherwise, you will always have that doubt in your mind. And now I think that doubt is no more in your mind. Now let's study how to calculate or how to determine the number of significant figures if we are writing a number in scientific notation. How do we write a number in a scientific notation? For example, if the number is 1, 2, 3, 4, 5, its scientific notation is 1.2345 into 10 to the power of 4, right? Only one digit to the left of the decimal, all other digits are to the right, and to compensate it we are putting 10 to the power of some number. Okay, in this case, to find out the number of significant figures, we can simply neglect this part, and we can calculate the significant figures in this part, and that is your answer. Very simple. Okay, so let's take another example. 2030. We know these two are significant figures, and because of that this one is also, but this is not a significant figure, and when you write it in the scientific form, it is 2.03 into 10 to the power of 3. We can neglect this, and 1, 2, 3. Here also we have got 3 significant figures. So that is the way we are finding out the number of significant figures when we are writing a number in scientific notation. One thing you have to note is whenever we are writing a value according to different units, for example, you can write 23 meters, and this is same as 2300 centimeters, and this is same as 0.023 kilometers. At all these values or in all these three expressions, the number of significant figures are same. Here 1, 2, here also 1, 2, because we are measuring this value up to meters only. We are not measuring it up to the precision of centimeters. You can write 2 zeros only. So that's why we have told that these 2 zeros doesn't have significance, because they are not providing you the enough precision. So these two are not there in the number of significant figures. And similarly here also, these 2 zeros and this 0, now you might have understood, they are just holding their position because we had to convert the unit from meter to centimeter or to kilometers. So in all these three cases, the number of significant figures are 2, and which are all they? These 2 and these 3. These 2 zeros and this 0, they are just holding their position because we had to change the unit. Okay? Now let's do some examples very quickly, recalling all these rules. Okay? How many significant numbers are there in 91? Both are non-zero, so 2. Here also each and every digit are non-zero, so there are 5. 1, 2, 3, 4, 5. Here 1, 2, 3, 4, 5. There are 5 non-zero numbers, and this 0 is coming in between 2 non-zero numbers, and similarly this one also. So both these zeros are also significant, by which there are total 7 significant numbers. What about this one? 1, 2, 3, 4. And what are these 2 zeros? Are they significant or not? Yes, they are significant, because that they are trailing zeros after decimal places, and that gives you accuracy also. So 6. And what about this one? 1, 2, 1, 3. Okay. And are these 2 zeros significant? No, they are just standing, holding their places, right? So only 3. What about this one? 73,000. These 3. Here also they are just holding their places, only 2. And what about these 2? you can neglect this one and this one. Here 3 non-zero numbers, so 3 significant figures. Here 1, 2, 3, 4 and last trailing 0, by which there are 5 significant figures. Okay. So at this point I'm stopping this video because I feel like if I'm taking the next topic also, the video length will be very big. Okay. And that topic is all about determining the number of significant figures in a number when you're doing arithmetic operations. That's very simple topic, don't worry anything about it. And in this topic, what all things we have covered? We have covered just what do you mean by significant figures and those 5 rules. And always keep it in your mind that significant figures, they give you an idea of how much precise the measured value is. Okay, so keep on practicing from your textbook, from Google or somewhere else. Keep on practicing it. That's it for this video. See you in the next. Until then, bye, take care. Jai Hind.